In this video, I'm going to be talking about fractional distillation of crude oil. Crude oil is a fossil fuel that consists of different kinds of hydrocarbons. Hydrocarbons are molecules that consist of hydrogen and carbon. By itself, crude oil is not very useful as it can't be used for much, but it can be refined into a variety of different substances that can be used, for example, for fuels and for other materials that can be used to make plastics, detergents, asphalt, and many other products. Many of the hydrocarbons in crude oil are these molecules called alkanes. Alkanes are a homologous series with the general formula of CnH2n plus 2. Some examples of alkanes are shown in these diagrams here. Let's look at them in a little more detail. Methane has 1 carbon and 4 hydrogen atoms, so it has a formula of CH4. Ethane has 2 carbons and has a formula of C2H6. Propane has a formula of C3H8, butane has a formula of C4H10, and pentane has a formula of C5H12. These are examples of smaller alkanes, but the largest alkanes in crude oil can have as many as 35 or more carbons. In order to get crude oil into a usable form, you need to be able to separate out these different components with different sized alkanes. The different components of crude oil are separated into fractions of similar hydrocarbons through a technique called fractional distillation. This technique takes advantage of the different boiling points of different hydrocarbons. The separate components can then be used for different purposes. In fractional distillation, crude oil is heated until it vaporizes and is then passed into a fractionating column. The temperature changes as you move up the column, so the column is hotter at the bottom and cooler at the top. The vapor from the heated crude oil rises through the column. Depending on their boiling points, different hydrocarbons exit the column at different heights. Smaller hydrocarbon molecules have lower boiling points because they have weaker intermolecular forces. Larger hydrocarbon molecules have higher boiling points because they have stronger intermolecular forces. As the vapor rises through the column, the larger molecules with the higher boiling points condense into a liquid at higher temperatures. They are therefore collected at the bottom of the column. Smaller molecules with lower boiling points condense into liquid at lower temperatures, so they are collected at the top of the column. The smallest molecules have the lowest boiling points, and they leave the top of the column as a gas. The different fractions that are collected from the fractionating column are used for different purposes. A substance called bitumen contains the largest hydrocarbon molecules with the highest boiling points. This can be used, for example, in asphalt and for roofs. Other fractions with smaller molecules and lower boiling points are used, for example, as fuel for cars or for cooking. Through the process of fractional distillation, crude oil can be refined into substances that are useful for a variety of purposes.